Hello students, I am Gurmeet Singh. Welcome to CREATA CLASSES and also welcome to our series on triangles for class 10 student. Note that this complete series is as per the latest updated syllabus, and in this complete series we will cover all these chapters using the power of animation and the visual tool to make the tough concept easier for you. This is the last lecture of the complete series. In this lecture we will cover the revision of the complete series, and the link to all the lectures is given in the description. Check it out. And students, one important thing, do not forget to download the PDF of the concept and formula list. The link is given in the description. That will be really helpful to solve the question and also brush up the concept whenever you are having the exam or whenever you need so. So without taking any further time, let's start with this lecture. Best of luck. This lecture is all about the similarities of the triangle, which is somewhat matching with the congruency of the triangle that you have done in the previous class 9. Congruency and similarities are somewhat same concept, so you should know the difference between them. In the congruency, the two figures are having the same shape and same size. We can say two figures are congruent if they are exactly copy paste of each other. Their size are also same and their shape are also same. While in the similarities, two figures are similar if they are having the same shape. Two figures having the same shape, we can say they are similar to each other. Here, size does not matter. Size can be smaller, size can be larger, or size can be same. The only thing that matter in the similarity is the same shape. So congruency is having two components, same shape and same size, while similarity is having only one component, that is same shape. So we can say all the congruent figures are also the similar figures. But the opposite is not true, that is all the similar figures are not the congruent figures. Got it? Congruency is having one additional component as the size, and similar figure can have the same size or cannot have the same size. It does not matter. Only thing matter is they are having the same shape. Same shape means we can increase the size or decrease the size of one of the figure and exactly match with the other figure. Then we can say both are having the same shape, that is they are similar to each other. Here these two figures are similar to each other. We can take the right hand side figure, we can decrease the size or increase the size, and both will exactly match with each other. Moving further, there are some geometrical figures which are always similar to each other. For example, if we take the circle, you can take any circle, larger circle, smaller circle, any radius of the circle. Here all these circles will be similar to each other. You can increase or decrease the size of all these circles, they will exactly match with each other. The other geometrical figure in the same criteria is the square. You can take any number of square, big, small, any square, just decrease or increase the size, they will match each other. Means all the squares are having the same shape. The third and the last example in this category is equilateral triangle. You can take any equilateral triangle, any dimension. If you increase or decrease the size, they will match with each other, or we can say they are having the same shape. So we are having three examples which are generally asked in the examination: circle, square, and equilateral triangle. These geometrical figures are always similar to each other in their own category. Got it? Moving further, if we talk about the similarities of the polygon, how we can check any of the two polygons are similar or any of the two figures are similar or not. In case of polygon, we are having two conditions. If the two conditions are matching, then we can say the given polygons are similar to each other. The first condition is that the corresponding angles should match with each other. Here in this two figure, these are the corresponding angle. If all these corresponding angle, the respective corresponding angles are equal to each other, we can say our first condition is matching. That is, the corresponding angles of both the figures should match with each other. The second condition is regarding the corresponding sides. The first is regarding the angles, second is regarding the sides. The second condition is that the ratio, note that the word ratio, the ratio of the corresponding sides should also match with each other. Here we will take the corresponding sides, these are the corresponding side. We have to take the ratio, we do not have to equate the corresponding side. We have to take the ratios of all the corresponding side, and the ratios of all the corresponding sides will be equal. If the ratio of the corresponding sides are equal, then we can say our second condition is also matching. If both the conditions are matching, then we can say the two polygons are similar to each other. If only one condition is matching, second is not matching, then we can conclude the figures are not similar to each other. Matching of both the condition is must to check both the figures are similar or not. Note that this is for any polygon. You can take pentagon, hexagon, triangle, square, any polygon. These two conditions, these concepts will remain the same. And in this chapter, we are doing the concept with respect to triangle. So triangles are also a type of polygons. Like the basic form of polygon is a triangle. So in the triangle also these conditions are matching, that is the corresponding angles should match with each other and the ratio of the corresponding sides should also match with each other to prove or show both the triangles are similar to each other. But triangles are having a certain additional property that we do not have to every time check both the conditions. We are having three criteria specially for the triangles. Let's see. The first criteria is angle, 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 that is AAA criteria. As per AAA criteria, if only the corresponding angles of two triangles are matching with each other, then the two triangles are similar to each other. We do not have to go for the second condition, that is corresponding sides. The ratio of the corresponding sides will automatically be equal if the corresponding angles are matching with each other. So as per angle criteria, if we are having two triangles and the respective corresponding angles are matching with each other, then we do not have to check for the ratio of the corresponding side. The second condition, the two triangles will automatically be similar to each other. So this is the first criteria. Second is side, 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 that is SSS criteria. As per this criteria, if two triangles, the ratio of the corresponding sides are matching, then the two triangles are similar to each other. We do not have to check for the corresponding angles. The corresponding angles will automatically be equal. So in the second condition only we will check the ratio of the corresponding side. Note that here we are not matching the corresponding side. We are matching the ratios of the corresponding side. This is important. This is different from the congruency. So here ratios is very important. Do not forget this in the mid of the examination. This is important. The third is side, angle, side, that is SAS criteria. As per this criteria, if in the two triangles the ratio of the two corresponding sides, two set of corresponding sides are equal and the angle in between the two given corresponding sides are also equal. Here in this case, these two set of corresponding sides, the ratio is equal and the angle in between the two corresponding sides is also equal. Then we can say the two triangles are similar to each other by SAS criteria. So these are the three criteria or the three similarities rule through which we can check the two triangles are similar or not. So we have understood the concept of similarities of the triangle. Let's also understand how to write two triangles as similar to each other. This is very important and students generally do mistake in this part. Suppose we are having two triangles ABC and DEF. Here angle A and angle D are the corresponding angle which are equal to each other. B and E are the corresponding angle and C and F are the corresponding angle. We will write the two triangles as similar to each other as triangle ABC is similar to triangle DEF. This is the symbol of the similarity. Here both the triangles are similar. The point to be noted here is that the corresponding angle should be in the same order. Here A and D are the corresponding angle, so they should match each other. B and E are the corresponding angle, so they are matching, and C and F are the corresponding angle, so these two angles are matching. The order is very important. ABC should match with the order DEF. If you are having two triangles and you have to write the two triangles as similar to each other, just rotate the triangle, flip the triangle, do whatever it is required to make the corresponding angle side by side. Here A should match with D, B should match with E, and C should match with F. Then only you will be able to write the sequence of the vertices of the triangle in order. So this is one of the important concepts that students generally miss out. Let's move to the next concept, that is the BPT, Basic Proportionality Theorem. Let's understand this concept. Let's have a triangle ABC and let's draw a line DE which is parallel to BC. DE can be anywhere. It can be on the upper side, lower side, on the mid part, anywhere, but it should be parallel to BC. Both of these line segments should be parallel to each other. If these line segments are parallel to each other, then the ratio of AD upon DB is equal to AE upon EC. So the ratio of these four line segments will be equal to each other. In the form of exact wording, the theorem: if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Here point D is dividing the side AB into two parts, AD and DB, and E is also dividing the side AC into two parts, AE and EC. So AD upon DB will be equal to AE upon EC if DE and BC are parallel to each other. This is the concept of BPT, basic proportionality theorem, BPT theorem. We are also having the converse of the theorem, that is, if these ratios, that is AD upon DB is equal to AE upon EC, then we can say DE and BC will be parallel to each other. This is the converse of the BPT. And in the theory part, while taking on the question, we have understood that how to solve the question. In the question, we have to identify the parallel lines. Once we identify the parallel lines, we will try to draw a triangle around the parallel lines or identify the triangles around the parallel lines. Once we got the triangle, we will apply the BPT theorem or the converse of the BPT theorem. Various questions we have taken down in the question parts. Okay, and we have also understood how to solve the questions related to BPT. So that's it for this chapter. Note that you don't have to write this concept. Check out the link in the description. We are having a complete PDF of the concept or the formula list. That PDF can be helpful to solve the question and also do the revision before the exam or a few days before the exam, whenever you want to brush up the concept. Okay? So students, we have done with this lecture. Hope you have enjoyed the lecture created using the power of visualization, our unique way of teaching. And do not forget to download the formula and the concept list. The link is given in the description. And also this series or this lecture is part of the complete series on the triangle. The link to all other videos are given in the description. Also check it out. So thank you very much for being with CREATA Classes. Have a great day and meet you in the next lecture. Bye for now.